In this video, we're going to discuss multiplication and division of monomials. Let's start with multiplication. You can only multiply two monomials if they have the same base. They can have different coefficients. They don't need to have different coefficients, but they can. And they could have different exponents. Again, they don't need to have different exponents, but they can have different exponents. Now, what do you do when you're multiplying them? Keep the base and add the exponents. If your monomials have coefficients other than 1, then you will need to multiply the coefficients by each other. Let's look at an example. Let's say we have x squared, and we're multiplying it by x cubed. Do they have the same base? They both have a base of x. Do they have different coefficients? No, they don't have different coefficients, but that's okay. They both have a coefficient of 1. Since it's a coefficient of 1, we can't ignore it, so we will. Do they have different exponents? Yes, they do. They don't need to have different exponents, but in this case, they do. So what do? We keep the base, and we add the exponents. 2 plus 3 is 5, so x squared times x cubed is x to the 5th. Let's try one that has coefficients other than 1. Let's say we have 2x to the 5th times 4x cubed. Do they have the same base? They both have a base of x. Do they have different coefficients? Yes, they do. The first one has a coefficient of 2 and the second one has a coefficient of 4, but that's okay. Do they have different exponents? Yes, they do. That's also okay. They're allowed to have different exponents. So what do? We keep the base, add the exponents. 3 plus 5 is 8. And we multiply the coefficients by each other. 2 times 4 is 8. So the answer is 8x to the 8th. Let's try another example. Let's say we have 2x squared times 4y squared. Do these two monomials have the same base? You can multiply the x squared times the y squared in this example because they have different bases. What you can still do, however, is multiply the coefficients. You could multiply 2 times 4 and get 8, and the x squared and the y squared will just both stay there. You could put multiplication signs between them, but you don't need to, and it looks nicer when you don't. It's just 8x squared, y squared, and that's the answer. They stay like this. You can keep the bases and add the exponents. This is the answer to the question. Now let's discuss division. Division of monomials. So you can only divide two monomials if they have the same base. If two monomials have the same base and you want to divide them, it's okay if they have different coefficients and it's okay if they have different exponents. They don't need to have different coefficients and different exponents, but they can, and it'll be okay. So what do you do if you want to divide two monomials with the same base? What do? Keep the base and subtract the exponents. What do you do with the coefficients? Divide them by each other. Let's look at an example. Let's say we have 4x squared divided by 12x. The easiest way to think about this is by writing it as a fraction. 4x squared divided by 12x. So the first thing we want to do is we know that we're going to be, since they have the same base, they both have a base of x, we're going to keep the base and subtract the exponents. Whichever exponent is bigger, that's where the variable stays. So the x squared over here is in the numerator, so we do 2 minus 1, and we keep the x in the numerator. If we had the bigger exponent in the denominator, let's say we had 4x over 12x squared, then we would keep the x in the denominator. But in this case, the x stays in the numerator because x squared is bigger than x to the 1. Now we're going to divide the coefficients. What's 4 divided by 12? 4 divided by 12 is 1 over 3. So this is your answer, 1x over 3. Let's look at another example. Let's say we have 3x to the 4th divided by 10x to the 7th. Let's write this as a fraction to make it easier. Now they have the same base, different coefficients, and different exponents. Let's divide them. We're going to subtract the exponents from each other. Now, since this x to the 7th is in the denominator, we're going to do the bigger one minus the smaller one, 7 minus 4, and we're going to leave the answer, x to the 3rd, in the denominator. Now we can divide the coefficients. 3 divided by 10. Either we could divide it either on the calculator or in your head if you know that it's 0.3, but we could also just keep it as a fraction because the fraction can't be reduced anymore. We could just keep it as 3 over 10. So this becomes 3 over 10x cubed. And that's the answer to the question. Let's do one last example. Let's say we have 4x squared divided by 9y cubed. Do these two terms have the same base? The first one has a base of x, the second one has a base of y. Since they do not have the same base, these two terms cannot be divided by each other, therefore they stay how they are. You could also rewrite it as a fraction, it doesn't matter. You cannot simplify this anymore, you cannot divide them because they have different bases. We're going to do just one more quick example. Let's say we have 7x to the 4th divided by 14y. Let's rewrite this as a fraction and see if we can divide it. 7x to the 4th divided by 14y. Do these two have the same base? They do not. The base of the numerator is x and the base of the denominator is y, so they really cannot be divided. But what you can do is you can reduce the numbers. You can reduce 7 over 14 to 1 over 2, but you will have to leave the x to the 4th how it is and the y how it is.